is system Verilog? Okay, so we'll go to the introduction. What is system Verilog? Why we are going for system Verilog? First of all, what is system Verilog? System Verilog is HVL language, which is the hardware verification language. So we all know Verilog, right? So Verilog is which language? It is HDL language, hardware design language, right? Hardware description language. So that means, in Verilog we can write the design code as well as we can write the the test bench also. So why we are coming to system Verilog? So what the purpose? Why we are coming to system Verilog? So some advantage would be there. Yeah, some things would be there. So for that purpose we are coming to system Verilog, right? So the advantage of the system Verilog is, let's consider half adder. So as we all know, we can write the test bench in Verilog also for half adder. But why that is? System Verilog test bench environment we need. What's the requirement of our system Verilog? So the answer is, we can write the test bench in Verilog also, no issues. But whenever we'll have the bulky design, whenever we have the multiple n number of input, so for that, it is very difficult to manually to address the signals and all. So for that purpose, we'll go to the system Verilog, where we can have the interfaces, where we can input the signals, where we can give the direction of the signals. Okay. And that's why we're coming to system Verilog. And other benefits also we have, class concept we have, and other many concepts we have. Coverage we have, assertions we have. In coverage we can exercise our design code. In assertions we can validate our design. So these many advantages we have in system Verilog. So that's why we're coming to system Verilog. So let me explain. You can consider, it is not IP. You can consider like anything. It is like. It is the what to tell, if you have the system, right? You don't know about associative leaf. So this is you can consider this is the counter, and you can consider this is also another counter. But you have here multiple inputs, okay, up to 100, and here also you have the multiple inputs like 1 up to 100, okay, 1 to 100. So you want your input 1 should be connected to your input 3, and you want your input 4 should be connected to input 1, okay. So and up to 100 signals, okay. If you write the test bench in Verilog, no, up to 100 signals. So it is possible, we can write. There is no issue, we can't write, we can't write. We can write the thing, but what will happen? Okay, manually you need to connect the input 1 to input 3 and input 2 to input 4. So it will be take more manpower, right? It will take more time, it will consume more time. But in our system Verilog, what we have? We have the interface, okay. There is no need to worry to connect these things manually. We have the interface. In interface, what we'll have? We'll have the interface module. Then after we'll have the clocking block, and after we'll have the mod port. In interface, we need to define the signals and all. Interface is nothing but the bunch of signal. Okay. So in interface, first you need to mention inside the module you need to mention what interface signals and all. Then in clocking block provides the synchronization between the duty and the test bench. And coming to mod port, here how you know this particular whatever the IP or whatever you can tell, the input is going to the another IP input 3. So how you will know? By the mod port. Mod port will give the direction of the interface. Okay, signals, and that's it. So that's why we're going for the system Verilog. Then what is verification? Exactly what we are doing in verification? We are verifying our design. Let's consider half adder we have. Okay, the input is A and B. What the property of the half adder? If input A equals to 0, if B equals to 0, your sum has to be 0 and your carry has to be 0, right? So that time, whether how you will get to know you are getting this or not? You write the code, whatever the design given by designer or anything. You haven't written the code, but you don't know whether it is working fine or not. So for that purpose, we need verification. We need to make the test bench. And how to verify the design? Okay, multiple things are there to verify the design. In our system we have the randomization concept, where we will give the random input to our design so that to check whether it is whether we are able to verify or not. Then why as I told you, okay, why we have extension of the system Verilog as compared to Verilog. Okay, we have the multiple data types also we have, and system Verilog is dynamic also. and system Verilog provides us the coverage and assessment. So that's why we are going for system Verilog. Then let's go start with data type. Data type is nothing but when you are declaring the variable and you want to know which type it should be. Okay. Example int a. Okay. So a here a is your variable, right? So I mean this a variable, which type of data type it will store? It could be integer, it could be int, it could be logic, it could be bit, it could be byte, it could be event, union, struct, whatever you want. Okay. As for your requirement, which type of data you want to store. So this is called data type. So that's why we're going for the data type. That's why we have the data type to declare whether int a. So a is the variable, a can store int type of the data type, right? So in system Verilog we have the 2-state data type and 4-state data type we have. So what is 2-state and what is 4-state? Let me explain. In 2-state, we can evaluate the input. Okay, it could be 1 or 0. But in our digital system, in our digital circuit, we may also get, right, high impedance and unknown value. So who will evaluate that one? If we have 2-state, then who will evaluate? That's why in system Verilog provide us to 4-state data type. Logic, reg, time, and integer. These are 4-state data type. And int, short-int, long-int, bit, byte. These are the 2-state data type. That means it can evaluate only 0 or 1, 2-state. 4-state means it can evaluate 0, 1, x and z. X is nothing but unknown, z is nothing but high impedance. And here it is like mentioned signed and unsigned. I think people have like I heard about like signed and unsigned, which is like unsigned is positive and the signed is like positive and negative, both it can take. So array. So array is nothing but the collection of the element. Okay. If like you have declared the data type, you want to store the collection of the data, right? So that time we'll go for the array. Array we have 2 types. One is static array, one is dynamic array. Static array means we can't change the element, okay, at the runtime or simulation time. But coming to dynamic array, we can change the element, okay, at the runtime or at the simulation time we can change the value. So this is the main difference between static array and the dynamic array. So a static array comes under packed array and unpacked array. Dynamic array, we know dynamic array and associative array. Okay, these and all comes under dynamic array. And packed array and unpacked array. See, in packed array, it represents a contiguous set of bit. Okay, it is treated as a single vector. And single vector means you can give the like identifier. You can give the identifier. The single dimension you can give. Multiple also you can give, but moreover we focus on the single. Then we have the restrictions in the packed array. It can only take like bit, logic, and reg data type in declaration. It doesn't allow like integer, int, byte, bit. It doesn't allow. So here you can see. Here is the this is for the single, and this is for the multi-dimensional array. So single, logic. Okay, I'll show to you the memory declaration how it is happening. So that time you will get the clarity. Here is the unpacked array. As I told to you, it is the storing element is not continuous. Okay, so this is the one difference. And here we can take any data type. There is no restrictions like here. As I told, okay, we can only take. Here, as I told, we can only take bit, logic, or reg. We can't take int, byte, and integer. But here, there is no such restrictions. You can take like anything. So, coming to memory declaration. See, this is the memory declaration for the packed array. Here, if reg 5 down to 0, you can give. There is like this is single dimension, right? You can take like 5 value. One, array you can take. It will take the 5 value. That's it. But coming to 2-dimensional, here what you have given 2 down to 0 bit. You can store the bit here. Okay, the meaning of this syntax is okay. What are the array you have here? You can store the bit type and 2 down to 0 and 3 down to 0. That means 2 down to 0 means 3 like this. Row will come, and in that like 3 down to 0. That means the variable can store 4 bit. So 0, 1, 2, 3. This is for like 1. 0, 1, 2, 3. This is for 2. And 0, 1, 2, 3. This is for 3. Okay. So here 2 downs to 0 means 3 you have taken. Okay, I mean 3, I mean what to tell, yeah, 3 array you have taken. Okay, array 0, array 1, array 2, and the value you can store 4 4 0 1 2 3, like this way you can store. But coming to it, and it is serial, it is not parallel. I mean serial wise you need to store the data. But coming to unpacked array, the same 2 downs to 0 and 3 downs to 0. Here parallel you need to take. I mean array 0, array 1, array 2. Okay. So parallelly means parallel thread will comes into the picture. So 1, 2, 3, 4, then 5, 6, 7, 8, then 9, 10, 11, 12. But we need the three parallel separate, so it will take more memory. So in interview point of view also people ask the regarding this, which memory takes more, I mean memory allocation. Coming to dynamic array. Dynamic array is one dimensional array. Okay. As I told to you, we can change the value of the value of our element, okay, during the simulation time or run time. Okay. So this is for the syntax. This is the syntax for the dynamic array. Data type you need to give and array name, then this like square symbol you need to give. Coming to yes, beat 3 downs to 0 and B2. So here is the data type beat, and here you have given the size, I mean whatever the size you want. Not it is, we can't call this a size, but this is the whole size of the our particular array. We can store up to 16 element. Okay, more than that we can't do. So then we have given the symbol of the array. So here we have some methods like array methods, new, size, delete. Okay, new means okay, whenever you want to allocate the memory, that time you will go for the new. Then size means you want to know your current, whichever the current dynamic array you have, what the size of the current dynamic array. And delete, you know, okay, in dynamic array, if you want to delete means you need to delete whole array. You can't delete particular index. You need to delete whole array. So here is the syntax. Okay, as I told you, okay, int dynamic array. Okay. So initial begin, how you will assign the memory to the dynamic array. Every time you need to use the new keyword so that you can assign the value to the dynamic array. So new 100, that means I have like created one dynamic array. The size of the array is 100. I have taken. And coming to this line, if you want, I mean whatever the array you have, the size is 1000, right? But you need to have the existing array. With that array, you need to add some extra size you want, but without deleting that one. You need to have the existing array, but without deleting that one, you want some 10 more value, some 10 more indices would come. So that time you will go for this syntax, like new dynamic array dot size, then plus 10. So new 10 size will come. So now here we have the 100 size. So now it is added 10. So it is 110. Coming to associative array. So associative array, when the data space is unbounded, whenever you don't know the size of your data. I mean whatever you want to store in your array, but you don't know, you are not aware about the size of your array. So that time we'll go for the associative array. Remember this one, this is like very important point. Yeah, I mean what is the difference between dynamic array and associative array? Mainly whenever you know about the size of the array, right? So that time we'll go for the dynamic array. But whenever you don't know the size of the array, okay, so that time you go for the associative array. So associative array syntax is like this way, okay, beat 3 down to 0 array int. That means this is the associative array which is 4-bit and the index is 2-state data type. That means you have created the array, but you can store in that index, okay, the index should be int. So this is the syntax of the associative array. And if it comes to, if we will go to the memory perspective, memory view, no, I can tell to you, wait, how associative array and other thing, associative array, it takes less memory as compared to dynamic array. Dynamic array takes a lot, not lot, but yeah, as compared to your data size, it takes a more memory as compared to associative array. I'll tell how. See, here your associative array is there. Here is your dynamic array. I don't know like much more time to to do that one. So you can understand here you can take the indices size 1, 2, 3, 4, 5, 6 and value is also same 1, 2, 3, 4, 5, 6. This is dynamic array. This is associative array. So let's consider you have given the size is 4. Okay. So whenever you want to modify your size, okay, but you have like given the size of the array is 4, but you didn't store 4. You just store up to 3. You didn't store 4. So again you are assigning the size in dynamic array. What it will happen, you know, it will start from 4. It won't start for 4. It will start from 5. It won't start for 4. Why? Because dynamic array property is like this way. Okay, whenever you have assigned the size, again you are resizing means it won't go. Okay, it won't go to the previous size. Even though you have declared, even though no value is there, but it won't check. It will go to the 5. Even though the size you have like given 4, okay, but you didn't store up to 4. You store up to till 3. You store 4. You didn't store. But once again you resize, no, it will go directly 5. It won't check like whether in the 4 index you have any value or not. It won't check. But coming to associative array, it will check. It will check the previous value whether it is covered or not. So if it is not covered, it will store in 4, then again 5, then again 6. So that's how our associative array saves the memory as compared to dynamic array. So here also you have the methods num, delete, exist, first, last, next, previous. Okay, in exist, okay, you want to know whether.
Can you repeat that? The difference related to the storing?
Yeah, sure. See, you can consider here index is also 1, 2, 3, like that you can also consider. Okay. So in dynamic array, you just like imagine you have given the size is 4. Size means you have already declared you want to store 4 variable. But you didn't store, in actual you didn't store 4. You store 3. Again you want to resize. Again you want to add more 3 element. Okay. But in reality you stored 3, right? But 4th place is empty. But in dynamic array it won't check whether the 4th index is empty or not. It will suddenly jump to the 5. Okay. It won't go to the 4. Why? Because you declared size is 4. So that doesn't matter. It won't check whether you have like given any value or not, or element is there or not. It won't check at all. It will go directly 5. So why? In this way, what is happening? In this way, this place is blank, right? It is empty, but it is taking the memory, right? Because you have indexes is there, right? It is taking the memory, but we are not storing anything. But in associative array, it is reverse. So whenever you are given the size, okay, 1, 2, 3, 4, even though you are storing 4, but associative array will check, okay, whether any space is there or not to store next value. So if is there any empty space, it could be 2, it could be 1, it could be index 3. So it will go first there and it will store the value, and it will check in another place where the empty place is there. It will check the value like that way. Understood?
Yeah.
Or any doubt again? If tell, I'll explain again if you have.
No.
Okay. So these are the method of if you want to check like your first value, you can use the first method, last method. If you want to like check the previous value, next value. So these are the method of the associative array. Coming to queue. Use a queue array when the insertion and extraction order are important. Okay, that means what? You have the queue, right? If you want to store any element, okay, that should be in the like insertion or extraction order. Okay, that time we'll go for the queue. Okay, and queue size is, remember this one. Queue size, it is like many times I saw in the real time project. It is like one dimension. Okay, I didn't see like multiple dimension queue size. Okay, so as per my experience, I made this PPT. So this could be one dimension. So here we have the bounded and unbounded queue. Bounded means what and unbounded means what? Bounded means you have given some certain size of the queue. Okay, that's what we call bounded. Unbounded means this dollar sign. You can store up to any element, up to 1,000, 2,000, 3,000. You can store the element. You can like define any size. This is called unbounded. And whenever you have defined the size, this is called bounded. So here is where you have given dollar. Okay, that means okay, this is unbounded. You have given $10. That means it can store up to 10 element. Okay. So this is and queue and string can grow. Okay. You can another thing is in queue you can delete the particular element. Okay. And another thing I forget to tell to you, in dynamic array and in associative array. In dynamic array, if you want to, if you want to delete this particular element, okay, but you can't delete in dynamic array. You need to delete whole array. There is no such option to delete particular element. But coming to associative array, we have this option. We can delete the particular element. Okay, that's what like I missed of the things. So in Q also we have the same. We can delete the particular like array. So mainly in Q we are using in the semaphore also we are using the Q. Okay, and in our test bench also, in UVM test bench also we are like mostly going for the Q. And it's depend upon your requirement what you want to do Q or associative array or dynamic array. Then we have the Struct and union data type. Anyone is aware about the Struct and union? Okay, leave. So what happened now? Whenever, okay, in our dynamic array or in your associative array or in your queue, okay, you can't have the connection of the data type. You need to take one. It could be int or it could be byte or anything. But you need to take one. You can't take multiple. Okay, but it is in Struct and union. It provides to us no connection of the data type. We can take the connection of the data type and manually we can give the value to our particular data type. Okay. So this is called Struct and union. But we have the difference. Okay. The syntax wise, these both are same. But the memory allocation wise, okay, it is somewhat different. Struct is different and union is different. I'll explain how it is different. I think you might have understood. Okay, if you have like declared no Struct int a bit by bit b and byte b and bit 7 down to 0 c. Okay, so you are given your data type name is my underscore data underscore Struct. So if I want to give any size to the int a, so what I'll do? Okay, in initial begin, okay, a equals to 25. Why? Because this is integer data type. So like that way it works. I'll tell how it is like make the difference. Struct and union. Sorry, don't go for my handwriting. See, this is Struct, okay. So, what Struct will do? See, here we have, where it is, yes. See, here we have int, byte, bit. In Struct, what it will do? It will check, the size of the data type, right? Int is how much bit, and byte is how much bit, and bit is how much bit. So it will check among three, which data type is allocating more memory, which is taking more memory. Let's consider byte. Byte is 32. Let's consider what it will do. It will allocate the size of the the byte is 32 first. Then, even though the int is not 32 or the bit is not 32, but it will allocate the same memory to all. First, it will check among this data type which is having more, which is taking more memory allocation. We can tell, right? If it is 32 bit, it is 64 bit. That means what? It is memory allocation, right? So it will check which data type is having more. It is taking more memory. So it will like pick like byte. So it took byte, and what it will do? Remaining, even though it is not, even though these two int and bit, they are not the same storing size, but it will take assign the same 32 like this way it will assign. It won't bother. So once first it will check, okay, how much which data type is having more memory size. So okay, if it is 32 bit, even though some data type they are not 32 bit, or if someone is like 664 and other data type it is not 64 at all, but it will take the data type as also 64. So that's what is happening. It is taking more memory, right? If you okay, why we came to this? Why means we want to store the memory, we want to save the memory, but here it is taking more memory. But coming to union, it is quite reverse. Okay, it will check. Okay, int is how much the data, how much memory it is taking to store. Byte is how much memory it is taking to store. Bit is how much memory it is taking to store. And as per the memory, as per the size of the data type, it will assign the memory. It won't go like a Struct. How Struct is going, right? 32 to 64 bit means okay, all the memories will be 64 bit. No, it is like it is increasing the memory size, and it will make our processor slow. So that's why we're going for the union. Mostly we'll go for the union. Then what is class? We'll go for the class concept. First of all, class is a dynamic data type. Remember this one. These questions like mostly often asked by interviewer. What is class? You can tell at first. Okay, class is a dynamic data type, which is having the properties and methods. Okay, what is called properties? Properties called this index. Method called is what? This task. Method could be task or function. Properties means okay, for which input you want to perform. This is called properties. Simple. Okay, properties and method we have. Properties here what? Index you have given. Okay, so task set int I. So you just want to give x equals to I. Then end task. Okay, so here a equals to a, then space a1. That means you have created the handle for class A. As you can see, class A is there. So A is the name of the class, right? So here A1 means you are creating the handle. See, remember one thing, in class directly you can't send any value to the particular like class. Okay, if now you will tell I can send directly A equals to 2. No, you can't do. You need to do everything by the handle of the class. You need to create the handle of the class. Then through the handle you can assign the value. Until only, if you will think directly you will assign the value to the class by the class name, so it is not possible. You need to create the handle for this one. So this is the handle. We can tell instance also, A1. Okay. So then after A1 equals to new, that means it is allocating the memory to the particular class. New means, remember in system Verilog, wherever you will see new means, that means it is like allocating the memory. For allocating the memory, we are using the new keyword. Okay, so here we are like allocated the memory to our class A through the handle class A1. So if I want to call this particular task, okay, what I'll do initial begin, then C1 dot set. C1 means A1. Sorry. A1 dot set. That means you want to call this task. Task name is what is here, set, right? You want to call this task. Okay. That too, you have written the class in the class. You have written the task in the class, inside the class. You want to call that one. So what you need handle to access any element, any method, any properties. So you should have to create the handle. So through the handle you can call that class properties, or you can tell, okay, if I want to assign x value to 2, you can assign no issues. You can assign A1 dot set equals to 2. So that means you just like want to assign x value equals to 2. So like that you need to assign. If you want to call this task, then A1 dot set. Set is the task name. So like that we will do in our class. Sorry. We'll go for the deep copy and shallow copy. First of all, what is copy? Why I want to do copy? That means, okay, in general way, if I'm like making anything I'm like preparing, or any presentation I'm making, or anything I'm writing, if I know this like previous content, I have two content. Okay, I have already created one content, and second content I want to create, but the similarity, I have the similarity with the first content. Some lines are same. So we are not going to write again and again, right? What we will do, we'll copy that particular line and we'll paste there. So this also play, that copy method also play here also, but it is quite different. See, in shallow copy, this is the packet P1. That means packet is your, it could be class. Okay, packet is your class. You have created the handle for the packet. Packet 2, we can tell packet 1 and packet 2. Wait. Packet 1 and packet 2. So P1 and P2, these are the handle. As I told to you, you need to make the handle to access any properties or any method of the class. So P1 equals to new. That means you have assigned the memory to the P1, not P2. But here what you will do? Wait. You have like created the handle for the P1. but you want to copy that P1 content to P2. So no need to create another object for that one. In remember in shallow copy, we can copy the properties, okay, but we can't copy the method. We want this one. Properties we can copy, but method we can't copy in shallow copy. Okay. So simply you have like created as you have created the handle for the P1 and P2. So just like you copied P2 to P1, that means okay, you have like send the data of the P1 to the P2. But in deep copy it is quite reverse. Okay. You need to assign the two. You need to assign the memory to the two handle. P1 and P2. So individually you need to assign the memory to the handles. Okay. Then after you need to do P2 dot copy P1. So whatever the content you have in your P1, it is copying to P2. That means including the methods also. The properties and the methods both will copy in deep copy. So other concepts also we have. Is there any doubt?
In shallow copy, you have just assigned the handle. Isn't it the handle assignment only?
What? I didn't.
Not the shallow copy. For the shallow copy.
In shallow copy, we have like see here also handle only we need to do. There is no issues. But for the memory allocation, what I have done? I have done for P1 only. I haven't done for the P2, right? Only for P1 I have done. So I was like, copying the content of the P1 to P2. Okay, that too excluding the methods. It won't copy the methods. It will copy the properties only. Actually, I have less time, right? I was like about to write the code and to explain to you, but I have like I think 1 hour almost I have. So that's why the moreover the things I'm giving. So later if I'll get chance and I'll explain to you clearly. Okay? Hello?
Yes. Like for the shallow copy, there is a syntax like PT is equal to mu of P1. So this will be the shallow copy. And the directly we are doing here P2 is equal to P1. So it will be the handle assignment only, object assignment only. Isn't it?
Wait. You can write in this way. You can write in that way also. Okay, it is also fine for this. Shallow copy. You told this is the handle assignment. Yes, this is the handle assignment. You can only assign the handle. Okay, we are not like copying. We are not doing the deep copy. Right? This is the handle assignment. You told the correct. But the thing is, once you run the code, no, you get to know. How it is happening. Okay. How to explain? Okay, if I have time, then I could explain. But P2 equals to P1. You have certain method like your properties like beat 7 down to 0 data, or another property you have byte 7 down to 0 address. Okay, and methods you have you just want to add like A and B. Okay, methods it could be task, it could be function, it could be anything. But in shallow copy, what you will do, the properties you have now P1 and P2 both class you have for P1 also for P2 also, but it will change the size and it will change the it will change the size. Okay, of our properties. Okay, in your shallow copy, you can give the display statement and you can see there. Okay, like that it happens. But coming to deep copy, it will change the methods also. Okay. Hello.
Yeah.
Hello.
Yes.
It is clear, or I need to explain again?
No,
I know. No, it is for first time. No, you will face some difficulty. Why? Because first time means you need to go through the whole concept. But we don't have time that much of time. If I would have, then I would for sure I would explain by taking the properties, methods, and adding the display statement and running in the EDA playground. I can show to you, but less time I have. So next time if I get chance, for sure I'll explain. Okay. You can't, at first time, if someone gives the overview, no, it is somewhat difficult to understand. I can understand that one also. Coming to polymorphism and inheritance concept. Other concepts also we have, encapsulations also we have, data headings also we have, but it is it will take somewhat longer time, so we'll focus on the polymorphism and inheritance. What is inheritance? First of all, you have one class. Okay, let's consider you have one class. Okay, and you are extending that particular class to another class, right? You have the parent class and you have the child class. How child is coming? Without parent, child can come? No. Child means it is coming from the parents, right? So you are extending the child class from the parent class. Okay. So here, as you can see, we have two classes, child and parent. But without changing, I mean, without changing the parent, what to tell, properties and method, we need to, we need to access the value or the property or the method of the parent. Okay, through the child handle. We can't access the properties or method of the parent directly. For that we need to have the child handle to access the properties or method of the parent class. Okay. So moreover, the inheritance means it is like extending something we are inheriting from something. So we have the parent class, we are inheriting our child class through the parent class. Okay. Without changing anything. Then after what we are doing, we are accessing the properties and method of the child class, parent class to the handle of the child class. I'll explain how. Wait. See, here is you have the parent class. Here properties you have, method I didn't add, but coming to child class, the same properties you have. Okay, method means it will take some time to, what to tell, for the beginner level it will take some time to understand. So that's why I have like only added the properties. Okay, so child in the parent class you have these 3 down to 0 data. In child class you have int id. Okay, so what you want to do, you want to assign some value to data and id, right? Here what's our motto? We want to assign some value to our properties. Okay, so module class example, initial begin we have like given. Then we have created the handle for the child. Here you can see the child class we have. Okay, child class, you can take the child class. Okay, child class, you have created the handle for the child is c underscore tr. So you are assigning the value to the child new c underscore tr equals to new. That means you assign the value to your child class. Okay. Then you want to access the properties of the parent class. But here see, I haven't like created any handle for the parent class. Only this is the handle for the child class only. So I am accessing the child properties also, as well as I'm accessing the parent properties also. This is what? This is parent property, right? This is what? This is child property. Data is what? Parent property. ID is what? Child property, right? So I'm assigning 5 to the parent property and I'm assigning the 1 to the child property. Okay. Through what? Through the child handle only. Here we have the restriction. The child can access the properties and the method of the parent, but the parent can't access the properties and method of the child directly. We need to have the child handle to access the properties and method of the parent class. Is it clear? Hello? Is it clear, right? I'll move on to, okay, fine. So, we'll go for the polymorphism. Polymorphism quite rare reverse. It can give the poly means what? Many forms, right? So, we'll go to the many forms later, but first we need to understand what is polymorphism. Same concept we have. We have child parent class it is extending from the child class, but here it is reverse. The child can access the properties and method of the parent, as well as the parent also can access the properties and method of the child also. Okay, through the parent handle, the child handle. So here, as you can see, I haven't like created the classes and all, but just I have taken directly. See, for the parent I have created 2 handle. For child I have created 2 handle. Okay, c underscore a, c underscore b. Wait. So here what we have done, we have like created the child handle c underscore a, the child handle c underscore b, but here we have the parent handle also p underscore a and p underscore b. Okay, but I didn't write the class, whole class I didn't write, but just like I have like written the handle and all. So so here we have like c underscore a the handle, c underscore b the handle. So I am like assigning any value, c underscore data equals to 2 and c underscore b equals to 3. But what I will do here, as we know p underscore a, what is this? This is the parent handle, right? So what I am doing, I am assigning the value to the p underscore a equals to c underscore a. That means c underscore is what? Child handle to p underscore a. So also I am like assigning the value like c underscore a to the p underscore a and c underscore b to the p underscore me. That means this is the handle assignment. It already happened. So the data is the parent property. Okay, the data, remember, I mean I didn't write, okay, but I'm telling the data is the parent property. Okay, so I want to access the parent property. Okay, how I'll access, as we have like seen here you can see again. See, here we are taking only child handle. Even though we are accessing the parent properties also, but through the child handle we can access. We can't have access through the parent handle. And here we are not creating any parent handle also. Why? Because we don't need. But here we have created the parent handle also. And the data, this particular data, as you can see my cursor, this particular data is the property of the parent class. Okay. So I'm like assigning the 100 value to the property of the parent, that too through parent handle. This is parent handle p underscore a. You can see here I have like created the two handle for the parent. So what to say, I'm sending the value, or I'm like storing any value to the data through parent handle. So it is possible in the polymorphism, but in inheritance it is not possible at all. Then we'll go for randomization. What is randomization? Why we need randomization? What's the requirement? I think you have. I think you people might have like done the $random, $u-random in Verilog. Exactly what we are doing in there. We are giving the random input to our data to check. Martin. Hello. Anyone is speaking? Anyone is telling anything? Hello. Okay, fine. So randomization is what? It is the process of producing random value to the method, to the particular method or data type. We can tell data type also. So in randomization, moreover, if we tell why we need randomization, what the requirement of the randomization. See, manually if we give one input to the hapad, two input to the hapad, three input to the hapad, how much time it will take? But instead of doing that one, what can we do? We can set the value, we can set the range, like rand bit 4 down to 0 value. So what it will do? It will give a random input our duty so that it can verify easily. So we need not to be worry, okay, 1, 2, 3, 4 manually we need to give. No, we'll give the rand and 4 down to 0. That means what? 16 possible value will come. So it will give the duty and it will check the inputs. Okay, this is called randomization. So we have the two. We have rand also, we have the rand keyword also, we have the rand C also. In rand keyword, what will happen? If like I have given rand 4 down to 0, that means 1 to 16 possible value will come, right? That 1 can repeat 2 times also, 1 can repeat 3 times also, 2 can repeat 2 times also, 2 can repeat 3 times also. Okay. And for any value inside like 1 to 16, it can repeat more times also. Okay, 2 can become 2 times, 3 can become 4 times. So what will happen? Some confusion will happen while seeing the report. While seeing the what to tell our while running the UVM code. No, so you will see. So you'll get the confusion. Okay, so that's why we're going for mostly we won't go for the rand C, or we whenever we require, that time we'll go for rand C. In rand C, what will happen? It will come in cyclic way. The 1 will come only once. If we are given 4 down to 0, that means 16 possible value will come. Okay, 1 to 16. That means 1 will come only once. 2 will come only once. 3 will come only once. Okay. It won't repeat. In rand keyword, how it was repeating? 2 can come 2 times, 3 can come 3 times, like that it was repeating, right? But in rand C keyword, as you can see, rand beat, here you can give rand C. So what will happen? In cyclic way, it will come. So if we don't need the repetition, then it's fine. We'll go for the rand C. So we have two types of randomization: pre-randomization, post-randomization. What is pre-randomization? If we want to do any activity before the randomization, okay. If I want to disable my constraint, if I want to add something, okay. So what I'll do, I'll go for the pre-randomization, okay. But if I want to override anything, if something is there in my constraint, so if I want to override that one, so I'll go for the post-randomization. So mainly post randomization is useful when we are overriding our constraints. Okay. So this is called Part-3 and post randomization. We'll go for constraint. Now the question will arise, what is constraint? And why we are going for constraint? If I tell constraint is also giving the random input to our duty, then you can tell, okay, we have the randomization, why we are going for constraint. But the thing I'll explain, why we are going to constraint. If I want to, okay, we have 4 downs to 0, right? 16 possible value will come. But I want to give the, 4 to 8 inputs to my duty. I don't need all. I'll ignore all. I need only 4 to 8. That time what? Condition occur. That time what happened? I need this condition only. This condition input I need to give to my duty. I don't want to give whole inputs. Okay, like 4 down to 0, 16 possible value. Okay, 16 possible value. I don't want to give my duty. What I want to give to my duty? Some range I want to give, 4 to 8. So some range or any condition. Okay, like that way when it comes, no, we'll go for the constraint. Okay, so this is called constraint. So we have the constraint mode also. If I want to, okay, if I have like written 3 constraints in my class. If I want to, if I want to disable one constraint, I go for the constraint disable mode 0. If I want to enable, then mode 1. So like this type of like constraint we have, mode 0, mode 1 to disable our constraint, to enable our constraint. Okay. So constraint type is we have like inline, inside, for, each, bidirectional, solve, before, if, else, soft. Inline means you have the constraint. How to explain? Okay, I think you all are beginner. Okay, fine. I'll try to explain to you. Inline means you have the particular constraint. Okay, 4 down to 0. That means 1 to 60 possible value can become, but I want to randomize 4 to 8. Okay, at my first constraint, at my class I want to explain. Okay, I want to randomize, but later I realized, hey, no, actually 4 to 8 I want, but later also 10 to 12 also I want. If I forget that time, what I will do inside my module, when I'll assign when I'll do the activity and handle and other creation, that time by using with keyword, I'll give the range, okay, again 10 to 12. That means our simulator, it understood one thing. That one is, okay, I need to give the value 4 to 8 at the same time 10 to 12 also. This is called inline constraint. Inside constraint means if we are giving any range 10 to 12 or 10 to 15, okay, so you'll go for the inside constraint. For each means we all know, right? If you're taking any array, if I want to perform any array thing, if I want to add some element, if I want to perform some condition, if I'll tell, okay, do one thing, you generate one sequence like 0, 1, 2, 3, 4, 4, 8, 9, like that sequence you want to generate through the constraint. What you will do? Okay, you will go for the for each. Okay, why? Because you will take the array and we'll do the for each and some conditions we need to add, then it will perform. And bidirectional means, okay, it will perform in parallel way. Okay, if constraint A, B, C, 3 conditions you have, so it will execute in the parallel way and no one will be dependent upon no one. Coming to solve before, if you have, let's consider if you have the enable pin and you have the you have the enable pin and D latch you have. You want until unless your enable pin is high, your D latch will not perform. So what you will do? Solve before. Solve enable before D. That means first it will solve it will enable the enable. First it will solve the enable. Enable has to be high, then only the performance will happen. It will perform, otherwise it won't perform. Okay, this is called solve. Soft constraint means, okay, as I told you in inline constraint we are like facing some issues. Okay, while if we have like given the same range 4 to 8 and in your like with keyword, by using with keyword you are giving the some nearby that range. So what will happen? Some conflict. Your simulator unable to understand your particular. In your properties you have given bit A. Okay. Let me explain in Paint. It would be good, I think. In inline constraint, you have the class you have created here. The writing is somewhat difficult here. Okay, fine. Okay, class. Then after run beat, 4 turns to 0, data. Okay, so here you have taken the class. Okay, ran beat 4 down to 0. That means data you have taken, that size should be 0 to 16. But at the same time, while something you are writing, some conditions and all you are writing, I'm not going for the detail. Okay, in your soft constraint, in your inline constraint, you want to wait. Okay, leave. So class, okay, in rank bit you have like created 4 down to 0 data, okay. But in your inline constraint, you have like given already data size 4 to, I mean you want data size 4 to 8. You want your data size of 4 to 8, okay. 4 to 8 you want, okay. You have already, I mean, like you have already written inside your, I mean main constraint, okay. You have written already 4 to 8, right? But by using the with keyword, the same data variable you are taking like data 4 to 10. And in the module while you are I mean creating the handle and all, that time also we are giving data to 10 to 12. What your simulator will consider? Whether it is that, I mean 10 to 12 or whether it is 10 to 8. See, here we have 4 threads, okay. Fork, this is fork, thread 1, thread 2, thread 3, thread 4, and in join, I have some display statement, okay. So, here for the fork 1, sorry, the thread 1, what I have, I mean the delay is 1, and here for thread 2, the delay is 3. Thread 3, the delay is 2, thread 4, delay is 1. In fork join, how it will work, let me explain properly. So, first it will go to whenever you run, okay, whenever you run like this type of code. So first it will check, particularly in your fork join, it will check which is having the smallest delay, which is having the smallest delay. This thread 4 is having the smallest delay. First it will execute thread 4, then it will go to thread 3. Why? Because thread is having again, as compared to, I mean first delay I have like completed, then second delay, second is which is like is having less delay, 2 is having less delay. So it will go to the hash, I mean thread 3, then after thread 2. Why? Because thread 2 is having 3, then thread 1 it is having 5, okay. Until unless this 4 thread execute, it won't come to join statement. It will execute first this 4, then after it will come to the join statement, okay. It won't come to join statement until unless these 4 threads are executed. This is the properties of the fork join, okay. So, and it will check the smallest delay, which is having the smallest delay. From that side it will start executing, okay. So this is fork join. Coming to fork join any, okay, the same example, fork join any, it will when the, I mean it will come to the first fork block, it will see which is having the smallest delay. Here the thread 4 is having the smallest delay, okay. Fork join any means what? Any of the one. First it will check, okay, any of the one it is executed, okay, fine. That means thread 4 is executed, so it will come to the join statement. It won't, I mean execute the whole, I mean thread 1, thread 2, thread 3, no, it won't execute. First it will check, which thread is having the less delay. Whichever thread is having the less delay, first it will execute that one, then after it will come to join statement. Then again the simulator will go to the this fork join block. Again it will check again which is having the what to tell, again smallest delay. 2 is having the smallest delay. Then again it will execute the 1 or 2, then after it will come to the join statement. So it will keep on going, like this way, okay. But coming to fork join none, in fork join none it will happen, what will happen, it will come to first the fork block. If it will see any delays there, it won't execute it, it will go to the join directly, it won't wait. You understood, right? In fork join, even though delay we have, whatever we have, it has to execute the all threads, then it has to come to join. Coming to fork join any, it will check any one of the which is having the smallest delay, it will execute that one, it will come to the join statement, then it will be keep on doing the same thing until unless we complete our all threads, okay. In fork join none also, it will check which is having the less delay. But if I mean what to tell, if all are having the delay, then it will come to the join. It won't wait for the what to tell, the for thread 1, thread 2, thread 3, thread 4. It won't wait. It will come to the join directly. Why? Because delay is there means it won't wait. If delay is not there, it's fine. It will execute it. It will come. If delay is there, it won't wait for that one. So this is threads. Then coming to coverage. What is coverage? I have written one code. Okay. So I want to know whether how much of my code is exercised or not. I have written one design code, not I. If design engineer have written some code, that verification engineer wants to know whether that code, whatever the code is designed, it has properly exercised or not. That means it will check all the beans and all in coming to the functional coverage. Okay, code coverage. Okay. Let me explain in other way. I think you all are beginner. No. So coverage means it will first check. Okay, how many? What? Exactly. Whatever the things you have written in your design. No, whether I'm able to exercise this all possible conditions or not. Okay, that's what coverage. Moreover, if we tell, that's what the coverage. So we have two types of coverage: functional coverage and code coverage. Code coverage is also in code coverage also 4 to 5 types, like FSM coverage, toggle coverage, line coverage. This type of things we have in our code coverage, and we need to be bother about the code coverage. Why? Because code coverage will be generated by the tools. We are not going to do anything in the code coverage. It will be automatically generated by the tools only. But coming to functional coverage, we need to write. Functional coverage means what? I need to verify the functionality of my design code in terms of coverage. Okay. So in functional coverage, we'll have the beans and all. Explicit bean we have, implicit bean we have. Okay. So let me explain. In implicit bean, open. See, in implicit bin, what I'll have, okay, let me tell, okay, class I have, this is consider class I have, then beat, 7 down to 0, data. So if I want to cover all the beans, I want my all beans should be hit. Okay, that time I'll go for the implicit bean. And some we have the max also up to 64 we can hit. If it is going beyond that, more that one, then we'll do the automax bean. That means it will by default it will go for the 64 beans. Okay. So if I want to, hit all the beans, 7 down to 0, that means what? 2 to the power 8. How many beans will come? So I want to hit all the beans. I don't want to give any range, nothing I want to give. I want to hit all the beans. So I'll go for the implicit bean. Coming to explicit bean. Explicit beans we have explicit bean we have, ignore bean we have, illegal bean we have, transition bean we have, and wildcat bean we have. Okay, let me just give the overview of the explicit bean. Okay, same class beat 7 down to 0 data, but I want 10 to 20. I want to hit the bean. Okay, so I need to write the cover group. Okay, this is called cover group. Writing in short way. In cover point, okay, cover point, tp dot data bin equals to 10 down 20. Okay, that means here in explicit bin you can give the range up to what what you design exactly, what you want to exactly check in your coverage report, which bin you want to cover. Okay, so you will get this idea from your spec. You have the specification when you'll go to the industry, so that time you will have the idea. Okay, which bin I need to hit. If any range is there, so you'll go for the explicit bin. If I want to, hit 10 to 20. I want to see whether it is hitting or not. So I'll go for the explicit bin. Ignore bin. Let's consider I have one design. One signal is bypass enable. I don't want that one. What I'll do the ignore bin. I'll ignore that one. Illegal means I have the legacy project. Okay. So previous project I have. Okay. But I am making another project based upon the previous project. Okay. But the project I have certain number of additional signals. Okay. But in my previous project I have other signals. Similar. It is similar, almost similar. But some signals I'm changing in my new project. So what are the signals I have in my previous project? I don't want to add. What I'll do the illegal. That means this is not legal for the I mean for my current coverage, I don't want. Okay, so what I'll do, I'll do the what is it, illegal. Okay, and coming to wildcard bin, if I want to change the transition, if I want to change, if I want to check the transition like 1 to 10, by whether the transition is happening or not. I mean 1 to 10, the syntax is like this way. Wait. 1, then arrow mark, 2, 3. So if I want to check this type of sequence, okay. So what I'll go for the wildcard bin. Okay, I want to change certain sequence. In this sequence, the bin is hitting or not. Okay, 1 to 10, the bin is hitting or not. Okay, so if I want to change any sequence, I'll go for the wildcard bin. But coming to transition bin, if I want to check one, whether the transition is happening from 1 to 2 or not, or 2 to 3 or not. Okay, for single, so for to check the single, okay, 1 to 2 or 2 to 3 or 3 to 4 or 4 to 5, the transition is happening or not. So I'll go for the transition bin. Okay, these and all like coverage. So you will get the report. Okay, while when you will use the tool and all, so that time you will get the report. Okay, this is the coverage report. I mean 26% or 30% or 70%. So what you will do? How you will make more? I mean your coverage report should be 100%. How you will make? So you will write more number. You will add more number of bin. You need to consider scenario also. Which scenario you are escaping? What you are like forgetting? This is the manual work, right? I mean, this is someone is doing. This is not tool is doing. Okay, so something you might forget or some scenario you might forget to cover. So you go and you check and you will cover, and you need to make the coverage requirement 100%. Okay, by adding more number of pins in your coverage. And coming to assertions, okay. In assertions, what is assertions? Okay, mainly we are going for the assertion to validate our design with respect to clock. Okay, I'll tell if I have certain conditions. Okay, if I have certain conditions, I want to know. Let's consider this set I have, bypass enable I have. Okay, and I want to check my reset. My reset should be high. Okay, that time my bypass enable should be low. Okay, and other condition, when my reset is low, my bypass enable should be high. With respect to, I'll go for the assertion. Remember, you can't write assertion for the cover. Hello.
No, ma'am.
Okay. So, hello, Rajat.
Yeah, yeah, tell me.
Yes, completed it is.
Okay, fine. Okay, then thank you guys. You can leave the meeting. No problem. Thank you guys. Thank you.
Okay. Thank you.